Dear students, today we shall discuss about stoichiometry. Let us consider two beakers. In the first beaker we contain HCl solution and in other one we have NaOH solution. Suppose if we are trying to add this NaOH solution into hydrochloric acid solution, we observe something new chemical species are generated during this addition. So this is an instantaneous change. Before this addition, we have HCl and NaOH. These two are, when reacted with each other, they forms new chemical substances, and these are given as sodium chloride and water. In an equation form, this change can be represented as HCl plus NaOH gives rise to NaCl plus H2O. So before the addition of this HCl and NaOH, these two substances are known as the reactants. The formed new chemical substances, these are known as products. So in order to obtain a new product, this can be represented in a chemical equation form, which represented as like this. So this is a chemical reaction. This chemical reaction represents the qualitative change that occurs in the given process. So here when you observe this reaction, HCl reacts with NaOH. By observing this chemical reaction, can you get any information regarding how many grams of HCl and NaOH react with each other? And another question is, how many grams of NaCl water are formed in this reaction? Can you get these information in this chemical reaction? No. So we are not get any information regarding the quantity of reactants or products. So this equation describes qualitative process that takes place in the chemical reaction. In order to obtain this quantitative relation, that means quantitative means the how much amount of reactants we should take for obtaining some amount of products. So this is known as the quantitative relation. So in order to obtain this quantitative relation, we must know about the stoichiometry. The quantitative relation between reactants and products which are taking part in the chemical reaction was obtained by studying the stoichiometry. Stoichiometry describes the quantitative relation that exists between the chemical substances undergoing any chemical change. Literally, the stoichiometry is a combination of two words. One is the stoichion, which means an element. Another one is metron, which means measure. Stoichiometry deals with the measurement of elements, or previously we discussed that it gives a quantitative relation between the chemical substances which are reacting and the final products which are obtained in a chemical reaction. To obtain a quantitative relation between the reactants and products, we must thorough with the four concepts which are involved in stoichiometry. These four important concepts which we are going to discuss in this stoichiometry are: the first one is the law of chemical combination, which mainly deals with the chemical reactions. Coming to the next one, concept of mole, how the reactants react with each other to obtain a desired amount of products. This will be explained based on the concept of mole. Third one is stoichiometric equations, which means the balancing of equations. How to balance a chemical equation, this will be known by using this stoichiometric equations. And the final one is the stoichiometric calculations. Based on this stoichiometric calculations, we obtain a quantitative relation among the reactants and products. So the key point in this is the stoichiometric calculations. So before going to discuss about the stoichiometric calculations, we need the knowledge of these three aspects also. So let us start this law of chemical combination. As I already stated, this law of chemical combination deals with chemical reactions. As we know, a chemical reaction is represented as reactants gives rise to products. So this law of chemical combinations will mainly deals with the chemical reactions. The important laws which are governed by any chemical substance is are given by law of conservation of mass. Second one is the law of constant proportions, otherwise it is called law of definite proportions. Next one is law of multiple proportions. Next one is Gay-Lussac's law, and the last one is Avogadro's hypothesis. Based on these laws, chemical reactions were introduced by the scientists. First of all, let us go to law of conservation of mass. This law of conservation of mass was given by Lavoisier in the year 1744. So what is the statement of this law? According to this law, matter is neither created nor destroyed in a chemical reaction. Suppose if you take a chemical reaction, in this, matter can be neither created nor destroyed. That means we cannot create matter or we cannot destroy matter. Then what about this chemical change? Yes, simply the matter is converted from one form or one chemical substance into another chemical substance. To understand this law, let us consider a H-shaped jar which has two limbs. In the left side limb, we have taken silver nitrate solution AgNO3, and in the right hand side limb, we have taken the potassium iodide solution, Ki solution. A similar type of H-shaped jar is taken. In these two, we have taken the same amount of silver nitrate on the left hand side and potassium iodide on the right hand side. Now, if these two are placed in a balance, yes, this balance shows an equivalence point. So that means both are of equivalent weight. Now, if we take the right hand side jar and let us shake this thoroughly. After shaking this, the solution in the left hand side, that is the silver nitrate solution, will get mixed with the right hand side solution, that is the potassium iodide solution. When these two are mixed with each other, silver nitrate gets reacted with potassium iodide. How these two are reacted? Look at the equation involving these two. Silver nitrate AgNO3 plus potassium iodide Ki gives rise to AgI, silver iodide plus KNO3, potassium nitrate. In this way, the silver nitrate gets reacted with potassium iodide. We obtain new products. These new products are silver iodide and potassium nitrate. Now, after mixing these chemical substances, now we put this jar in the right hand side pan. In this case also, we obtain an equivalence point. So that means both are having the same amount. That means in the left hand side, the species, that means the silver nitrate and potassium iodide, which are not reacted with each other. When you consider the right hand side jar, in this, the silver nitrate and potassium iodide are gets reacted with each other so that they forms a new product. Those new products are silver iodide and potassium nitrate. Even the reaction is taking place between the silver nitrate and potassium iodide. This particular jar is having the same mass as that of the previous one. That means when there is no reaction between these two. From this, what we can conclude is, even if the reaction is taking place between the silver nitrate and potassium iodide or not, whatever it may be, the amount of the quantities present in these, that means the weight of these two jars is the same before the reaction and after the reaction. So that means the matter, that means the silver nitrate and potassium iodide, the same amount can be converted into the silver iodide and potassium nitrate. So this is observed by the equivalence point in the balance. So on the basis of this law, we conclude that for a chemical reaction, total mass of reactants before the reaction is equal to the total mass of products after the reaction. Yes, we have observed previously in the animation. On the left hand side, we have the reactants. This is the case for a reactants before the reaction. Coming to the right hand side jar, in this, the reaction is completed so that they forms new products. Here the mass is also same. So the mass of the reactants becomes equal to the mass of the products. Hence, matter can be neither created nor destroyed in a chemical reaction. And similarly, this logic is applied for all the chemical reactions. Next, we are going to discuss about law of constant proportions. This is also known as law of definite proportions. This was given by Proust in the year 1799. According to this law, a chemical compound always contains the same elements combined together in the same proportion by mass, or a compound always contains exactly the same proportions of elements by mass. So here a chemical compound always contains same elements, whether it is in the combined state, or a compound always contains exactly the same proportion of elements. So to understand this law of constant proportions, let us consider the formation of carbon dioxide. The carbon dioxide can be obtained by 4 different ways. These are represented here. The first one is by heating calcium carbonate, we obtain the carbon dioxide. So this can be represented in an equation form. CaCO3 on heating, it gives CaO plus CO2. So if you take calcium carbonate in a dry test tube, suppose if you try to heat this, we obtain the calcium oxide solid and the gaseous carbon dioxide. So this is represented in the chemical equation. This is one way of obtaining the carbon dioxide. And in a similar way, by heating the sodium bicarbonate, the carbon dioxide is also obtained. So this is represented in a chemical equation form as 2NaHCO3. This also on heating, it gives sodium carbonate and water molecule and CO2. In this way, the carbon dioxide is obtained by heating sodium bicarbonate. Coming to the next one, by burning carbon in presence of oxygen. So the suitable equation is C plus O2 gives rise to CO2. All these three methods are thermal methods. So that means after heating the concerned reactants, we obtain the carbon dioxide. Coming to the next one, by reaction between the calcium carbonate and HCl. Yes, acids when react with the carbonates, carbon dioxide is evolved. The necessary equation is given by CaCO3 plus 2HCl gives rise to CaCl2 plus H2O plus CO2. So these are the 4 methods to obtain the carbon dioxide. In all these methods, we obtain the carbon dioxide. If you obtain the ratio of mass between the elements, what are the elements in the carbon dioxide? One is the carbon and other one is the oxygen. So if you obtain the ratio between the masses of these elements, in these 4 methods, we obtain 12:32 as the mass of this carbon dioxide. So whatever the method we have prepared, the carbon dioxide will have the ratio of the masses as 12:32. So this ratio is satisfied whatever the chemical reaction, or if it is possible to obtain the carbon dioxide by any other way, the ratio of the masses of these 2 elements is same. So this can be best understood using the following problem. A sample of 1.375 grams of cupric oxide when reduced in a stream of hydrogen gave 1.098 grams of copper. On the other hand, a sample of 1.179 grams of pure copper gave 1.476 grams of cupric oxide when copper was in HNO3, that means nitric acid, and nitrate formed was heating strongly to get cupric oxide. Show that these data prove law of definite proportions. Look at the given problem. When you read out this question, there are two experiments. In the first one, 1.375 grams of cupric oxide. It is reduced in a stream of hydrogen. Then it gives 1.098 grams of copper. That means when you take 1.375 grams of cupric oxide, when it is reduced with hydrogen, certainly it gives copper. The amount of copper produced is given by 1.098 grams. Now, coming to the other experiment, a sample of 1.179 grams of pure copper, which gives 1.476 grams of cupric oxide. So, this is obtained adding this copper to HNO3 solution. So that in this way we obtain the cupric oxide. We have initially taken the copper, that is given by 1.179 grams, and we are obtaining 1.476 grams of cupric oxide. So the reactants and products are reversed in the second experiment. Now our aim is to show these data will satisfy the law of definite proportions or not. So look at the solution. Here, when you read this question, a sample of 1.375 grams of cupric oxide. So therefore 1.375 indicates the amount of cupric oxide present. How much amount of copper is present in this experiment? 1.098 grams. So the amount of cupric oxide what they have given 1.375 grams is equivalent to the amount of copper, and the remaining amount is present in the form of oxygen. 1.375 grams of cupric oxide equivalent to 1.098 grams of copper, and the remaining amount, that is 0.277 grams, is oxygen. Now, the percentage of copper in this particular sample is given by how we obtain the percentage sample? Yes, if you take the amount of copper divided by the amount of cupric oxide into 100, this gives the percentage of copper. So this percentage of copper is given by 1.098 divided by 1.375 into 100 is equal to 79.85%. So this much amount of copper is present in the first experiment. Coming to the second experiment, the composition of cupric oxide is, here in the given problem 1.476 grams of cupric oxide is present. So 1.476 grams of cupric oxide is equivalent to how much amount of copper is present? 1.179 grams of copper, and the remaining amount, that means 1.476 minus 1.179, the remaining amount, which gives the amount of oxygen, that is given by 0.297 grams. Now in this case, the percentage of copper in the sample is given by 1.179 divided by 1.476 into 100, which gives 79.87%. Since in the both experiments we obtain the same percentage of copper, when the percentage of copper is same, what about the percentage of oxygen? In the first experiment, the percentage of oxygen is equal to 100 minus 79.85, which is equal to 20.15%. Similarly, in the second experiment also, the same percentage of oxygen is present. So, whatever the experiment is there, the percentage of copper and oxygen is same. That means they have definite proportions. Therefore, the law of constant proportions is applied here. Next, we are going to discuss about law of multiple proportions. This law of multiple proportions was given by John Dalton. This law was based on the atomic theory which was proposed by John Dalton. According to this law, when two elements combine with each other to form two or more chemical compounds, then different amounts of one element which react with definite amount of second element are in a proportion of simple whole numbers. So to understand this law of multiple proportions, let us consider two elements A and B. When these two elements react with each other, they forms two compounds. These two compounds are labeled as X and Y. In these two compounds X and Y, different amounts of B reacts with same amount of A. Then these different amounts of B bear a simple whole number ratio with X and Y respectively. To understand clearly, you consider one more example. Here you take two specific elements. Those two elements are carbon and oxygen. When these two elements combine with each other, they forms two oxides. They are, the first one is the carbon monoxide and other one is the carbon dioxide. In carbon monoxide, the ratio of the carbon is to oxygen is 12:16, whereas in the carbon dioxide, the ratio of these two elements is given by 12:32. Now, the ratio of oxygen, that means this is the specific element we have taken. This element which is present in the two oxides, that means carbon monoxide and carbon dioxide, is given by, in the first compound it is 16, whereas in the second compound, that is carbon dioxide, it is 32. Therefore, the ratio of oxygen in these two compounds is 16:32 or simply 1:2. This is a whole number ratio. What the law of multiple proportions says that when two elements combine with each other to form two or more compounds, here carbon and oxygen react with each other to form two compounds. One is carbon monoxide and other one is carbon dioxide. The different amounts of one element which react with definite amount of second element. Here one element we have chosen is the oxygen. The amount of oxygen reacted with the carbon in these two compounds are in a proportion. This proportion is given by 16:32, which is a whole number which is given as 1:2. So this is in accordance with the law of multiple proportions. We came to another example. Here we take nitrogen and oxygen. When nitrogen and oxygen combines or react with each other, 5 different oxides are formed. These are all the stable oxides. These are given by nitrous oxide N2O, nitric oxide, dinitrogen trioxide, dinitrogen tetroxide. This is a dimer of NO2 and dinitrogen pentoxide. When you consider the first one, nitrous oxide, the ratio of the elements is given by 28:16. If you come to nitric oxide, it is 14:16. Coming to the remaining 3 oxides, the ratios are given respectively. Now, the amount of oxygen which reacts with a definite amount of nitrogen, say for example 28 grams. The amount of oxygen which reacts with 28 grams of nitrogen is given by the ratio. Here the ratio is taken over all the remaining oxides. Therefore, the ratio is given by first compound N2O. The weight of oxygen react with 28 grams of nitrogen is 16, When you come to the nitric oxide NO, here 14 grams reacts with 16 grams. So here we have taken 28 grams. So therefore amount of oxygen that reacts with 28 grams of nitrogen is 32. In a similar way, when you come to N2O3, here the amount of nitrogen is 28. Coming to the oxygen amount, it is 48. Hence 16 is to 32 is to 48, which is to 64 is to 80. When you cancel 16 on the remaining fractions, we obtain 1 is to 2 is to 3 is to 4 is to 5. So this is a simple whole number ratio that exists between the amounts of nitrogen and oxygen. We came to another example. If you take hydrogen and oxygen, here hydrogen and oxygen combines with each other to form two oxides. One is H2O, this is water, and other one is H2O2, this is the hydrogen peroxide. These are the two stable oxides formed by hydrogen. So if you have the ratio of the elements in H2O, this is given by 2 is to 16. Coming to the H2O2, the ratio is given by 2 is to 32. Now, the ratio of oxygen in H2O and H2O2 is given by, it is 16 is to 32, or when you make it simplified, it is given by 1 is to 2. Here, the ratio is a whole number ratio. Hence, the law of multiple proportions is valid in the hydrogen and oxygen combination also.